Hello, in this video let's discuss third question of today's Leetcode contest. You are given integer enums and integer k. Your task is to partition into k non-empty subarrays such that minimum possible maximums are among these k subarrays. And the constraints are n is up to 250 and the values are up to 199 and k is less than or equal to n. So we have to return the minimum possible maximum XOR of all k subarrays. So the first thing that comes is obviously binary search. So, but is that correct? It is wrong because mainly because of two reasons. The first one is we cannot apply binary search on non-monotonic functions because let's take this as the given array and let's assume that now we are trying to find for sum instead of XOR. So if we are trying to find it for sum, then what will be the prefix sum? It will be simply 13264 and for this one it will be 134810. We can apply binary search on sorted array or maybe we can apply only on sorted array, right? So we cannot apply binary search on this one. So obviously we cannot, if the values are surely increasing or surely decreasing, then we can try to think based on a middle value. But what if it's something like this, some zigzag? So for a middle value, we cannot decide whether the answer will lie in the left part or right part. So similarly, the case with the negative elements when we are think of sum as well. And similarly, it relates with XOR as well, because the XOR can increase up to some 0 to index I, and after that it can decrease, and after that it can increase, and it can follow some zigzag path. So we cannot simply take some mid value and based on that we cannot divide the subarrays. For example, we have some 10 elements in the given array, and the mid we are binary searching for is for example 10. So there can be multiple different subarrays where the XOR is 10. This can be the first one, this can be first one, and this can be the first one as well. These three can be subarrays with XOR 10. We cannot try each and every possible value for a mid value. So obviously we cannot do binary search because it is not monotonic. For example, if this is sum and if it is all positive numbers, then prefix sum is surely positive, and then we can apply binary search. Because for example, in this subarray, for the sum we are trying to find is 5. For example, we are trying to divide subarrays into greater than or equal to 5. So then we can surely break it at 1348 because this is the least index, and every index after this also will satisfy. But this is the least index that will satisfy. But we cannot do that in the case of XOR. Hope you get this. So we cannot apply binary search. This is the first reason why we cannot apply. And the second one is simply because of constraints. The n is up to 250. So surely n cube will work. So n cube can be one of the possible solution. So how can we think of n cube? It is simply dp because it involves trying every possibility, because let's say we have n square possibilities and we have n partitions. So it's simply it can be thought of n square subarrays into, for every partition we are doing some iterations. So it is n cube. So we can think of db. Now let's come to db. For example, this is the given vector, and for example we are at present index. The all information what we want to get the answer. Obviously we want from which index we are considering for our answer, and similarly what are the number of subarrays left, because we have to make sure we are dividing the array into k different subarrays. So surely it should be one of the state in the db, so that to specify whether we have done exactly k partitions or not. And the next one is, for example, we are at index 2, right? This is one of the possible subarrays that is there till now, v of 0 and v of 1. And now coming to v of 2, what are the cases that we can think of? The first one is simply continue the before one. So the new array will be v0, v1, v2. Continue with the before subarray or start with the new subarray from this. So we can break this and a new subarray can be starting from this. These two are the possible cases. So what is the information that we needed to get the XOR? We must want XOR as a DP state as well, because for example we are at this index, right? So how can we know the subarray XOR in the present subarray without the present one? For example, this is the before subarray. Let's assume this is from 0 and this is one subarray and this is some subarray and we are at this index. So when we are at this index, when we are continuing this, let's assume we are continuing this, right? When we are continuing this, at any point we will stop the taking the subarray. So when we are stopping the subarray, we have to know that this is the XOR of the subarray that we are considering. So obviously we have to maintain a state with XOR as well, which implies the present XOR of the present subarray continuing. So we want DP XOR as well. Else how can we get XOR? So the first thing we want is the index from where we are thinking to start a subarray. Initially it will be function of 0 because we are on in the whole array. So the whole array simply represents the first index is 0. And the second one is number of subarrays considered so far. which is the maximum value is k, and it will finally go to 0. And similarly, the third one is XOR in the present array, so that only then we can know what is the present XOR in the present array. So, but the XOR is up to 199 because the numbers are up to 199 or up to 199, and the XOR can be up to 199. So we cannot use this as state because the space complexity will be very high, and we can use only up to 185 or some 186 only, but not 199 for sure. So how can you do this? So what can we store to get subarray of some subarray I to j, XOR of some subarray? The main thing is here, for example, these are the subarrays considered so far, and now we are at this index, and somewhere we will try to end this subarray. Let's assume that this is the index that we are ending this subarray, this whole subarray. So we want the XOR of this subarray of 1. That is what we are discussing, as we cannot store that in the subarray in the DP state. So how can we find some subarray XOR I to j? So what if we try to store index I instead of XOR? So if we store index I instead of XOR, then we can try to do prefix XOR. Why prefix XOR? So let's say this is the given array, and this is the subarray we are considering to find the XOR for. So this is I and this is j. We want subarray prefix. We want XOR of all elements from index I to j. So the first thing is we can traverse O of n. So this is simply waste because it will increase O of n, time complexity by into n. We want it in O of 1 or O of log n. So what if we store every XOR from 0th index to every other element? So let's make a new prefix XOR vector where prefix XOR of I indicates all the XOR till elements from 0 to index I. So prefix XOR of 0 is 0 itself, v of 0 itself, and prefix XOR of 1 is XOR of all elements till index 1. Index 2 will be all till index 2. Prefix XOR 3 all will be till index 3. XOR and so on. So now when we want answer for I to j, isn't it simply prefix XOR of j XOR prefix XOR of I minus 1? Let's take a simple example. Let's assume that we are finding for sum instead of XOR. So this is the given array, and we want the sum of elements in index in the subarray 2 to 3 efficiently. So we can simply take a prefix sum. So it is 1. So it is 3. And now coming to this, the sum of elements till before is 3 and the present element is 3. So it will be simply 3 plus 3, which is 6. And similarly, and now the present element is 4. The sum till now is 6. So the total sum till now will be 6 plus 4, which is 10. And similarly, this is 15. And now we want answer for 2, 3. So what we want, it is simply 16. 6 plus 10. So how can we get that in terms of XOR? So it is 7 because this is the original array. It is 7. So how can we find 7 from the XOR prefix sum array? It is simply prefix sum of 3 minus prefix sum of 1, because 3 will involve sum of 0, 1, 2, 0, 1, 2, 3, and prefix sum of 1 will indicate for 0, 1, but we want for 2, 3. So simply these two will be erased. These two will be subtracted. The remaining will be 2, 3. What we want exactly. So for finding answer from I to j, prefix XOR of j XOR prefix XOR of I minus 1, so that all the before values from 0 to I minus 1 get cancelled, and only the XOR from I to j will be left. So in this way, instead of trying to maintain a XOR value in the DP state, we can simply store the index, the present subarray. For example, this is the old subarray, and this is the present subarray we are starting new at index j. So instead of XOR as a DP state, every time we are starting a new array, change the state to that index, so that every index continuing that subarray will use j to get XOR. For example, this is the index where we are starting the new subarray, and let's assume this is the index that we are closing the present subarray and starting the new subarray from k plus 1. So at index k, we have to know the XOR of the present subarray, so that only we can find the minimum of maximum XOR still now. So that if we are storing XOR here, we are storing j here. So now the main solution is to find XOR for subarray j to k, and we discussed before, it is simply prefix XOR of k XOR prefix XOR of j minus 1. So in this way, by simply storing an extra index, we are able to get the XOR in of 1. So, but what if I is equal to 0? What if, for example, we are trying to find the subarray XOR starting from index 0? From here we can see that I minus 1, which is not meaningful because 0 is the first index. So we want simply from 0 to j. What it is simply prefix XOR, because this is the definition, right? Prefix XOR is the XOR of all elements from 0 to that index. And similarly, we want from index 0 to j, so it is simply prefix of XOR. For every other index 1 to j or 2 to j, it is simply prefix XOR of j, XOR prefix XOR of I minus 1. But 0, it is a special case because I minus 1 is not correct here. So it is simply prefix XOR of j according to the definition. And now we got what is the DP states. The first one is index, and the second one is the number of subarrays considered so far. And the third one is the index of the first element where the new subarray started and where we are counting the present index. And now let's come to final transitions. So function of index present the number of subarrays considered and the number of present index present subarray, which is j according to our previous example. And now let's assume that we are trying to simulate for function of I comma L comma S. So we are at index I. We consider L is the L is 0 initially because new subarray is starting from 0 initially. So L is 0 initially. And the second one, the third one is the number of subarrays considered, which is 0 initially because we did not complete any subarray. We just started the subarray from 0 index. So ILS, it will be simply 0 comma 0 comma 0. Let's start simulating this. So let's assume that we are at index I, and what are the cases that we can think of right now? Continue the exist subarray. For example, that started from index L. So that started from index L, and now we are at index A. So just simply continue this. So simply continue. So how can you continue? It is simply I plus 1 L S. N and k are constants. Just remove. N is the size and k is the number of subarrays considered. So the first thing is I plus 1 L and S. So we are not making a new subarray. So this will not change. Because this will not change. Hope you understand this. We will update this only when we are starting a new subarray. But in this state, we are just continuing the subarray. So no need to update this. And also we did not close any subarray. We are just continuing. So similarly, the subarrays will not change. It will be simply yes. The only thing that changes is I, which will be I plus 1. Because we are starting from next index. Like we are finding the answer for next index. And similarly, what is the second case now? Second one is to stop a subarray here and start subarray from next index. For example, um, L is the starting index of the present subarray and we are at I. So now we are assuming that we are stopping the subarray at I and assuming that we are starting a new subarray from I plus 1. So how can we show this in terms of db? It will be simply function of I plus 1, I plus 1, S plus 1. Because we are starting a new subarray from I plus 1, right? So we are updating the index of present subarray. So it will be simply I plus 1. And also we are breaking a loop at present index. So simply we are increasing the subarray. So it will be simply S plus 1. And similarly I plus 1 because we want the answer for next index. And now we have to find the maximum subarray of maximum XOR of all k subarrays. So how can you find it? So it is simply prefix XOR. It is simply the prefix sum from L to I because we discussed before. So we want subarray XOR from L to I. How can we do this? We can simply compute a prefix XOR, and from prefix XOR X will be prefix of I. So whole subarray XOR L minus 1 when L is 0. So if L is 0, it is 0 we discussed before. If L is not 0, it is simply prefix of L minus 1 and XOR. So in this way we can try to find the XOR of present subarray often efficiently. So because let's assume we are at index I, we are breaking the subarray at index I, starting the new subarray from index I plus 1. So this indicates that we are starting a new subarray, and now this is a new subarray formed L to I. So we want to consider this XOR as this XOR also. So we want to find subarray XOR from L to I. So it is simply prefix I XOR this value. And after considering the both transitions, we have to store the minimum value because we have to return the minimum possible value of maximum XOR. So here we are finding the maximum XOR and here we are finding the minimum of possible XORs. And we are storing in dp I of L and S. And finally we can return the answer. So hope you understand this. Let's check the code. So we are inputting the values and initializing prefix XOR and making the prefix XOR. Initially function of 0 comma 0 comma 0. So if S is greater than equal to K, it means that we have crossed K subarrays. So which is wrong. So return very high value so that it will not be considered. And if that is not minus 1, so it means that it is computed before. So just return it. And we are computing the prefix XOR here. And now if I is equal to n minus 1, it means that we have reached the subarray. We have reached the whole array. So if it is k minus 1, then it is the prefix XOR itself because we are stopping a subarray here. So we are checking for k minus 1. So if that is k minus 1, so we are stopping the subarray here. So we are making an extra subarray to form. So it will be simply k. So if it is k minus 1, then the answer will be x, else it will be high value. Because if it is not k minus 1, it means that it is not valid possible breaking of given array. So we are returning high value even in this case. And the first case is continuous subarray, so it is A. And the second one is form a new subarray, which is B, and return the final minimum value of AB. So in this way we can find the answer. If you have any doubts, comment below. Subscribe for more updates. See you in the next one.